Hello, 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 hello.
Hello, hello.
Okay, let's start. We will today we will see the get questions. Especially we will see the topic wise, yes, and the subject wise get question. So the first subject we will choose the remote sensing, and we will try to solve the all previous year the remote sensing question which you have had asked in this get exam. So this is very useful, and we will try to understand the concept and this. So let's start. The first question that has been asked in the 2007, in digital remote sensing, land water contrast is best identified in the wave length bands. The option is ultraviolet, near infrared, middle infrared, and thermal infrared. Which one is the correct? So one by one, we will see the all options and why these options are wrong and why these options are correct. So let's see. The first things, ultraviolet. Water strongly absorbs UV radiation, but so do many land features. Atmospheric scattering is high in UV, reducing image quality, not ideal for land water contrast. So that's why ultraviolet is not useful. Near infrared, that is the B option. Water has very low reflectance in near infrared. Its electromagnetic range is zero point 0.7 micrometer to 1.3 micrometer. Due to a strong absorption appearing very dark, most land feature, especially vegetation, reflect strongly in NIR, appearing bright. This creates maximum contrast between land and water. And the upcoming option is the middle IR, that is the infrared region. This the range of the EM electromagnetic range of this uh, is 1.3 to 3 micrometer, but some minerals and dry soils also absorb, reducing contrast compared to near NIR. Thermal infrared shows temperature differences rather than reflectance. Water and land may have similar temperatures, especially in stable condition, resulting in lower contrast. Why NIR is the best? The stark difference in the reflectance properties creates the highest contrast. In NIR imagery, that is near infrared, water bodies appear almost black, white vegetation and soil appears bright, making water boundaries extremely clear. So correct answer is B, near infrared. The next question is a clay mineral and Fe oxide minerals, products of a hydrothermal alteration and supergene oxidation, are good indicators of mineralization. Choose the correct thematic mapper band ratio images for detection of these minerals. So the first option is that is a band ratio 5 by 7 for clay and 3 by 1 for Fe oxide. And the B option is the band ratio 3 by 1 for clay and 5 by 7 for Fe oxide minerals. Band ratio 3 by 7 for clay and 5 by 1 for Fe oxide minerals. Band ratio 5 by 1 for clay and 3 by 7 for Fe oxide minerals. Detailed analysis of Lancet thematic bands we will see and try to solve these options. The first band is the electromagnetic range between zero point 0.5 to 5.2 micrometer, and that is blue. Band 2 is zero point 0.5 to zero point 0.6 micrometer, that is green. Band 3 is zero point 0.63 to zero point 0.69 micrometer, that is red. Band 4 0.76 to zero point 0.9 meter micrometer, near infrared. Band 5 is 1.55 to 1.75 micrometer, that is shorter wave infrared, and band 6 is 10.4 to 12.5 micrometer, that is thermal, and band 7 is 2.08 to 2.35 micrometer, that is shorter wavelength 2. So in the case of the clay minerals, example kaolinite, montmillonite, have a strong absorption features around 2.2 microband, and that is band 7. And they reflect strongly in band 5, that is 1.5 to 1.7, and that is band 5 is this. So it is a ratio of 5 by 7 enhanced clay minerals, because numerator 5 high reflectance over clay, numerator 7 low reflectance over clay due to absorption, result high values where clay is present. That is correct. In the case of Fe oxide minerals, Fe oxide, example hematite, goethite, have absorptions features in the red portion, example 0.6 to 0.7 band, that is band 3, and they reflect more in the blue portion, that is band 1, and the ratio of 3 by 1 enhance Fe oxides. So numerator band 3 low reflectance over Fe oxide, denominator higher reflectance, resulted low values where Fe oxides are the present. So option evaluation match our analysis, 5 by 7 for clay and 3 by 1 for the Fe oxide. So this is the correct is A, incorrectly swaps the ratio, and C and D use inappropriate band combinations that do not target the specific absorption features. So correct answer is the A. And the next question is in remote sensing. DTM is abbreviation for this. We will see the one by one. Daytime mapping, digital triangular model, digital transfer meridian, and digital terrain. The correct answer is digital terrain. I'm not going into deep. And the after then the scale of an aerial photograph acquired from a height of 5,000 meter using a camera having focal length of 200 is 1 is to 50,000, 5,000, 1 is to 20,000, 1 is to 40,000, 1 is to 60,000. So detail analysis, the scale of vertical aerial photograph is calculated using the scale is the focal length f by flying height h. So here it is given the unit conversion, focal length is here 200 that is 0.2 meter, and flight height is the 500 meter. So calculation f by h 0.2 upon 5,000 is equal to 1 upon 25,000. Options these are 1 is to 25,000. Here it is not given 1 is to 25,000. So option evaluation, the option is 1 is to 55,000, 1 is to 20,000, and this. So option evaluation 1 is to 5,000 is just this one. Would require height f0 and 0 1,000 means incorrect. So B 0.05, h is equal to f. So 4,000 is closest, and 1 is to 4,000 is a 0.3. So h is f 0.05, 8,000 meter height, and 1 is to 60,000, h is equal to 12,000 meter. So while the exact calculation given gives 1 is to 50,000, option B is 1 is to 20,000 closest match among the given choices. This slide discrepancy could be due to the rounding convention in the exam. So the option is correct option is nearly 1 is to 20,000. So in satellite remote sensing, the next question is in satellite remote sensing, the spectral bands near 1.4 micrometer and 1.9 micrometer avoid because of absorption due to H2O and CO2 in the atmosphere, absorption due to ozone layer in the atmosphere, and absorption due to nitrogen in the atmosphere, absorption by vegetation. So detailed analysis 1.4 micrometer and 1.9 micrometer band. This falls within the shorter wave infrared region. Atmospheric transmission, Earth's atmosphere has specific windows where radiations can pass through with minimal absorption. So water vapor absorption H2 has a strong absorption band at 1.4 and 1.9 micrometer due to vibration rotational transition of water molecules. CO2 contribution, while CO2 has absorption features, they are less significant at these specific wavelengths compared to the H2O. So option evaluation correct is A is the correct. It means that the first absorption due to H2 and CO2 in the atmosphere. Water vapor is primarily absorber at these wavelengths. SWIR में water wavelength has been absorbed. These bands fall within the atmospheric absorption regions, making them unsuitable for surface observation. Incorrect ozone absorption is strongest in UV and far 9 to 10 micrometer and not at the 1.4 to oblique 1.9 micrometer. So incorrect, nitrogen is relatively transparent across most of the electromagnetic spectrum used in remote sensing. So D is also incorrect. While vegetation does not absorb in some infrared bands, the primary issues here is the atmospheric absorption, not surface absorption. Scientific context, these absorption bands are so strong that very little radiation reaches the Earth's surface and return to the sensor. Remote sensing system avoid these wavelengths to ensure usable data from the Earth's surface. Correct answer A, absorption due to H2 and CO2 in the atmosphere. So the next question is the spatial resolution of IRS lists third multispectral sensor of near infrared band is this 5.8, 5.8, 23-meter resolution, 70-meter resolution, and this 72 this resolution. So IRS is the Indian Remote Sensing Satellites are part of the India's remote sensing program. List third linear imaging self-scanning sensor. Third, the multispectral sensor, spectral band visible and near infrared 0.5 to 0.85 micrometer, that is band 3. Short wave infrared is 1.55 to 1.70 micrometer, band 4. Spatial resolution including near infrared 23.5 meter and shorter wave infrared is 70 meter, pan kilometer is 5.8 meter, not relevant. So option evolution is this and the correct is answer B, that is 23.5 multiplied by 23.5 is the correct answer. Which of the following bands in micrometer is not suitable for band observation in satellite remote sensing? A is 3.3, 6.3, and this one. Okay, we will take the 2 minutes break, then we will talk. Okay, the next question is that which of the following bands in micrometer is not suitable for Earth observation and satellite remote sensing? So the first option is a zero point 0.3 to 0.35 micrometer. This falls in ultraviolet range, specifically UVA, and the ozone layer strongly absorbs radiation below 0.31 micrometer, while some radiation penetrates between 0.31 to 0.4 micrometer. 0.3 and 0.35 micrometer is near the cutoff where atmospheric transmission is very low. So 0.53 to 0.58 micrometer, this is in the green portion of the visible spectrum. 0.49 to 0.58 micrometer where atmospheric transmission is excellent. 0.62 to 0.67 micrometer, this is in the red portion of the visible spectrum with high atmospheric transmission. And the 0.74 to 0.78 micrometer, this is at boundary between red and near infrared, still within the visible near infrared atmospheric window with good transmission. Atmospheric transmission cooperation: UV region 0.35 to 0.35, 10% transmission due to ozone absorption. Visible region, all other options more than transmission. Why 3.30 to 3.3 micrometer unsuitable? The ozone layer in the stratosphere absorb most radiation below 0.31 micrometer, even in the 0.31 to 0.40 micrometer range. Transmission is significantly reduced. Compared to the visible spectrum, sensor operating at 0.30 to 0.35 micrometer would receive very little signal from the Earth's surface. Correct is 0.30 to 0.35. On a photo scale of 1 is to 40,000, a square shaped open cast coal mine of 1 square kilometer area would have an area of, in centimeter square, 2.5, B is 4, C is 6.25, D is 12. Detailed analysis for calculation in map scales, we must square the linear scale factor. Given is a photo scale 1 is to 40,000. A unit on photo is 40,000 units on the ground. Coal mine area 1 square kilometer is this one. Step 1, convert ground area to centimeter square, 1 meter square, 10,000 meter square. And the one is this, and this applies scale factor for area, this linear scale factor. So calculation is just see here. Alternate methods for this. So area on photo is 6.25 centimeter square. So option evaluation, correct answer is this 6.2. So again we will see the question. On a photo scale of 1 is to 40,000, a square shaped open cast coal mine of 1 square area would have an area of in centimeter. So detail analysis, the first we will see detail analysis. For area calculation in map scales, we must square the linear scale factor given here. Photo scale on 1 is to 40,000, 1 unit on photo is equal to 40,000 units on the ground. That's the meaning. Coal mine area is 1 square kilometer. It means that this uh, 10,000 meter square. Convert ground area to centimeter. 1 meter square is equal to 10,000 meter centimeter square. And 10,000 centimeter square is equal to 1,000 to this one. And after then apply scale factor for area. Linear scale factor is 1 upon 40,000. Area scale factor 1 is upon 40,000 square is equal to 1 upon this one. And the calculate for the photo area. Photo area is a ground area multiplied by area of scale. So the ground area is this one in centimeter scale because we have to convert this in a same factor. And how to convert this one? The first is 1 kilometer, so this is in meter square, and 1 meter. So this one, then this number figure is a centimeter square. So just check this one and area scale factor. So convert this area scale factor. So finally, this answer, the alternative match is 1 square kilometer. This one. On photo is this one upon this. So 1,000 meter by the 40,000 is equal to 0.025 meter is equal to 2 centimeter per side. So area on this photo is upon this ground area multiplied by scale factor. So ground area is uh, 2 centimeter per side. The area on photo is this is multiplied 2.5 centimeter. This is so 6.25 centimeter square. And the next is a major thrust in Himalayas has resulted in an intense shearing of a zone about 0.5 kilometer wide on either side of the thrust, leading to landslides. Which GIS function can be used to display the shear zone? Contiguity, adjacency, spread, proximity, buffer, and search. So, see this question and read and try to solve this question. A major thrust in the Himalayas has resulted in intense shearing of a zone about 0.5 kilometer wide on either side of a thrust leading to landslides. Which GIS function can be used to display the shear zone? Contiguity, spread, proximity, and search. So, uh, detail analysis. The question describes getting a zone that extending 0.5 kilometer on either side of a linear feature. That is thrust. Option evolution. Contiguity adjacency identifies feature that shares boundaries. This would show adjacent polygons but would not create a specific width zone around a line. Spread refers to the diffusion or flow across a surface like water flow, not appropriate for creating a fixed width zone. Proximity buffer create a zone of a specified distance around a feature, perfect for creating a 0.5 kilometer buffer on each side of the thrust line. Total 1 kilometer wide zone. Search involves finding features based on criteria, not creating spatial zones. So in the case of the GIS context, buffering is a fundamental proximity operation in GIS. For a linear feature like a fault or thrust, a buffer of 0.5 kilometer on each side would create a polygon that is 1 kilometer wide center on the line, exactly matching the description of shear zone. Correct answer is a proximity, that is the buffer. C. Our next question is vertical exaggeration commonly occurs during the stereo viewing of aerial photographs. Where does it occur? In the photographs, in the terrain, in the stereoscope, in the perceptor's mind. Detail analysis. Vertical exaggeration is a perceptual phenomena in stereoscopic viewing where vertical dimensions appears exaggerated compared to horizontal dimensions. In the photographs themselves contain accurate geometric information. Vertical exaggeration does not exist in the images themselves. In the terrain, the actual terrain does not change. This is the perceptual effect. In the stereoscopes, while stereoscopes facilitate 3D viewing, they do not cause the exaggeration. They simply present the images properly. In the perceptor's minds, correct vertical exaggeration is a cognitive phenomena where the brain interprets the stereo model with exaggerated vertical dimensions due to the viewing geometry and perceptual process. Scientific explanation: when being stereo pairs, the ratio between the stereoscopic parallax, which affects vertical perception, and the base distance, which affects horizontal perception, creates this illusion, and the brain interprets the 3D model in the virtual dimension magnified the typically by a factor of this. So, correct in the perceptor's mind. In a remotely sensed data of a planet, the presence of a hydrosphere species can be inferred using the region of electromagnetic spectrum. Which one is the correct? Radio wave, gamma wave, infrared, and visible. So again, we will read the question. In a remotely sensed data of a planet, the presence of a hydrous species can be inferred using a region of electromagnetic spectrum in which that is the infrared. Then hydrous species contain water molecules. STR hydroxide molecular spectroscopy principle. Water molecules have characteristic vibrational modes that absorb a specific wavelength 0 to H stretching 2.7 to 3 micrometer, HOH bending 6.1 micrometer thermal infrared, overtone combination bands 1.4 micrometer and 1.9 micrometer, opson evolution. Radio wave 2 long wavelength interacts with large scale structure, not molecule vibration. Gamma 2 short wavelength involves nuclear processes, not molecule vibration. Infrared correct the fundamental vibration modes of water occurs in the infrared region, near infrared 1.4 to 1.9 micrometer, and middle infrared 2.7 to 3 micrometers. So strong absorption features for hydrous mineral. And the visible wave has weak absorption in visible light, not diagnostic. So planetary science of context is like mass and these things. So the correct answer C is the infrared, as I have told in starting the first question we have explained. Next question: on a scale map, the length of a fault trace on a horizontal plane is represented at 5 centimeter. The same on the 1:25 scale vertical and aerial photographies. This detailed solution. This is a scale conversion problem. Step 1: calculate ground distance from map. Map scale is 1 is to 10,000. Map distance is 5 cm. Ground distance, map distance multiplied by scale denominator. So 5 centimeter multiplied by 10,000, that is 50,000 centimeter, that is a 500 meter. So first read the question clearly, then we'll try to solve this question and what is the meaning of this, because this type of the question many time has been asked in the GATE exam. So first read the question and try to solve. So I we'll meet after 5 minutes. And one, so question is on a 1 is to 10,000 scale map, the length of a fault traced on a horizontal plane is represented as 5 centimeter. The same on the 1 is to 25,000 scale vertical aerial photograph is. Detailed solution. This is the scale conversion problem. So step 1, calculate ground distance from map. Map scale is 1 is to 10,000. Map distance is 5 centimeter. Ground distance is map distance multiplied by scale denominator. 5 centimeter multiplied by 10,000, that is 50,000 centimeter, that is the 500 meter. So step 2, calculate photograph distance for same ground distance. Photograph scale is 1 is to 25,000. Photograph distance ground distance scale is denominator. So 500 meter by 25,000 is equal to 0.02 meter is equal to 2 centimeter. Verification is the 2 centimeter on 1 is to 25,000, and 2 is to 25,000 is equal to 50,000 centimeter, and 500 meter match the ground distance, and the 5 centimeter on 1 is to 10,000 map, and 5 5 into 10,000, so 50,000 centimeters is 500 meters, same ground distance. So answer is the 2 centimeter. So a geological reconnaissance survey is being carried out using remote sensing multispectral data. Which set of the two bands data of the following appropriate? So this is the last question. After then I will stop here, and we will meet the next topic. So the question is, a geological reconnaissance survey is being carried out using remote sensing multispectral data. Which set of the two bands data of the following is the most appropriate for the mapping limonite bearing zone? Option first, a near infrared band and thermal infrared band image data. Blue band and red band image data. C, short wave infrared band and thermal infrared image data. D, thermal infrared band and X band radar image data. Detailed analysis of limonite. Limonite is a hydrated iron oxide mineral. Which characteristic is spectral properties? Spectral characteristic of iron oxide is strong absorption features in visible spectrum, 0. 0.4 to 0. 0.7 micrometer. Especially Fe plus 3 ions cause absorption at 0. 0.5 to 0. 0.6 micrometer, green, blue, and 0. 0.8 to 0. 0.9 micrometer. This creates a distinctive red color in rocks, hence red beds in geology. Option evolution. So near and thermal infrared NIR source vegetation well, thermal source temperature neither especially targets iron oxide features. Blue and red bands correct the blue bands, 0.45 to 0.52 micrometer captures the strong absorption as of iron oxide, while the red band 0.63 to 0.69 micrometer shows higher reflectance. The ratio of red oblique blue enhances iron oxide structures signatures. Short wave infrared and thermal infrared SWR is better for hydroxyl bearing minerals, not iron oxide. Thermal infrared and radar, thermal shows temperature differences, radar shows surface roughness. Neither specifically targets iron oxides. So, geological context. In multispectral remote sensing, iron oxide minerals like limonite are best detected visible bands, particularly blue and red, where their diagnostic absorption features occurs. This is why iron oxide enhancement often uses ratios for visible bands. Correct answer is blue and red band images data. So the correct answer is the B. So we are going to stop here, and after then we will meet next day. Thank you so much.